Hey guys, this video is just to talk you through the measurement DI, just a bit of support. So essentially, I'm just going to talk you through what you need to include in the report in terms of the calculations, okay? And just some support with the percentage wasted space calculation and also how many of your containers you can make per the big A0 sheet, okay? So let's just get into this. So first of all, for your calculations, you need to show these for each of your container designs. So as per the task sheet, you need to do 3 different container designs, okay? So I'm hoping everyone's done an easy one to start with. So maybe just a rectangular prism. And then your second and third one can be a bit more complicated depending on how hard you want to take it, okay? You might do a composite shape, that kind of thing. So you need to have a labeled diagram cross-section of the container with the items inside. So think of this one here as like your shoebox, so your rectangular prism, and you're looking as a top-down view, okay? So these are the items inside. So think of those as maybe glue sticks, because that's what most of us are doing, and that's the top lid of the glue stick. So from this, whoever's looking at your work can see how the items are actually packaged inside your container. So you need the calculations for the volume of one item, so one glue stick, and all of the items that would be in the container, and then the container itself. So these are the volume calculations. So this is an example here. So calculate the volume of one glue stick. Now, glue stick is a cylinder. So the formula for the volume for that is pi r squared times height. That will be on your formula sheet. And multiply that by the total number of glue sticks to give the total volume. So my example here, if I calculate the volume of one glue stick is, say, 45 centimeters cubed, so I plug it in my formula, that's what I get. So then the volume for 8 glue sticks would be 45 multiplied by 8, because there's 8 in here, to give 360. Okay. Now you can have between 8 and 15 items in your container. So if I had a container holding 12 glue sticks, then I would multiply by 12 instead of 8. Okay. Then you calculate the volume of your container. Now this video is not going to explain how to do that, so look something up for a specific shape. All right. So next, for each of your containers, you need to calculate the percentage of wasted space. Now this is figured out using your volume calculations, all right? So think of it as you've got your container, you've got your glue sticks inside. The wasted space would be these white gaps here. So space inside the container that's not taken up by the items. So to get that, you need to do, to get your wasted space in centimeters cubed, you have the volume of your container, subtract the volume for all of the items, the glue sticks, okay? So down here is my example. So if the volume of my container is 500 centimeters cubed, so I just kind of made up a volume for the purpose of this, the wasted space would then be 140 centimeters cubed, because using the 360, which was all of the glue sticks, 500 take away 360 would be that 140, okay? Now that you've got the wasted space, you can calculate a percentage wasted space. To do that, you have the wasted space divided by the volume of the container times by 100. So for my example, it would be 140 is the wasted space divided by 500, which is the volume of my container, times 100 gives you 28% wasted space. Okay. Now, the less wasted space, the better. Okay, for the most part, because if you're mass producing these containers to carry these items, okay, because that's the context of this task, the more wasted space there is, the more, I guess, money is being wasted on materials that are really not being used. So if the container could be smaller, then that's a bit more efficient and more cost effective, okay? So when you're comparing to figure out which container is the best, this is a key stat to consider. So the next thing, you do need a labeled net diagram, and you can search for the net of any 3D object. And if it's a composite shape, you might have multiple objects stacked on top of each other or something like that. You need the surface area calcs, and now that's not going to be in this video, so look up something else in order to get support with that if needed, or ask me. Now this one here, we need to calculate the number of containers manufactured from the A0 size sheet of cardboard. So basically, as per the task sheet, there's a big sheet of card which the containers are cut out of to be produced. So from the task sheet, the packaging sheets of cardboard are this size here. So this is given to you on the task sheet. Now, in order to figure out what to do here, the first thing you want to do is convert this to centimeters, okay? Now, the centimeter conversion is divided by 10 because there's 10 millimeters in a centimeter, okay? So that would give us a 168.2 by 118.9 centimeter sheet, okay? So that's probably the first thing you want to do. The second thing is to calculate the surface area of that cardboard sheet. Now it's a rectangle, so that would just be length times width, okay? So my example down here, my answer is 18,000. Now that's not the same as what you'll get when you do this multiplication, but it's similar enough, okay? Just for the purposes of this explanation. So then you need to divide the surface area of your container, of the net of your container, by the surface area of the cardboard sheet. So if I say that a triangular prism container has a surface area of 2,300 centimeters squared, again, I've just kind of made this up for the purposes of demoing. 18,000 divided by 2,300 gives 7.83. So that tells me that 7 containers can be made in one sheet. It also gives me other information. Now that's the main conclusion I want you to draw. And again, this is another aspect that you can compare your 3 containers with to decide which one's the best. All right. Because if if 7 containers can be made, 7 of this container can be made per sheet, maybe your second one, you could make 20 containers per sheet. So then that's something to consider as well in terms of cost efficiency, that kind of thing. All right. You could also figure out how many glue sticks could be carried per sheet. Okay. So just say, for example, this one makes 7 containers and those 7 containers hold 10 glue sticks each. That's 70 glue sticks total. Maybe your second container, you can make 20 of them, but they only hold 5 glue sticks. 20 times 5 being 100. So 70 versus 100 glue sticks being shipped out by one A4 sheet. Okay. So just something else to consider when you're figuring out which one is the best. Now I just want to focus on this leftover, this 0.83. There's something else you can do to show how much is exactly being wasted. So 0.83 is 83% of one container that is wasted. Okay, so 83% of this is what's being wasted. So what I can do is multiply the percentage by the surface area of my container, and that gives me a quantity that's being wasted. So out of the 18,000 centimeters squared on the A0 sheet, 1909 is being wasted. I can then figure out the percentage of the A0 sheet that's wasted. So I can get the wasted quantity divided by the total surface area of an A0 sheet times 100. And that gives me an answer of 10.6%. So I can say when that A0 sheet is cut out for the 7 containers, 10% of it, 10.6%, is wasted. Okay. So again, that wastage percentage is something that you can consider for which container is the best. Okay, guys, I hope this helped and good luck with the rest of your assessment. Thanks.